What this little segment is going to cover is a little bit on the background of what radon gas actually is, some of the concerns from a health standpoint, and options as an inspector and tester. There are several pieces of equipment out there that you can get. Some of them are very cost effective, others are quite expensive. Just depends on the caliber of tester that you want to be. We're going to talk about the training. Certain states have certain requirements. I'm not sure where everybody is at, so I will cover all the states later on in that section, and then we're going to talk about the mitigation methods that are typically used today. How this actually got started. If there's anybody in here that's actually gone through radon training, this is kind of the startup of radon. Just imagine that you were going to work, and you worked at a nuclear power plant. Everybody started to say, we need the workers to pass through some type of testing portal to monitor any radioactivity. And one day, one of the workers left, went home, got lunch, come back, and set off the alarm when they entered the plant. Believe it or not, this actually happened in Pennsylvania. The person's name was Stanley Watrous. After a complete investigation, the problem was actually traced to his home. His home was tested at over 2,700 picocuries. It's been broken, but there are houses that are in different locations in the United States that can test as high as 3,000 and 4,000 picocuries. The reason his was so high is he sets on a granite formation called the Redding Prong. It is a very large band of a granite formation that goes through Ohio into Pennsylvania, into New Jersey, and into New York, and then on up through. It has a very high uranium content. I can tell you that a lot of the states, the northern states in the United States, and the southern provinces in Canada have very high concentrations of radon. Measurements have been tested, been proven. In 1987, the EPA come out with regulations, and those regs and guidelines was to establish that a home could be safer at 4.0 picocuries. Contrary to what you may have heard as being a home inspector or any type of listening to some of the realtors, not all, but some of the realtors, they'll say that this home doesn't have radon. Well, it's not true. Every home has some level of radon. And it's been absolutely proven, beyond a shadow of doubt, that when a radon mitigation system is installed, it will lower the concentrations to safer levels. You might be thinking, is there actually a safe level? The EPA states no. It's just get it down as far as you can, and the guidance is 4.0 picocuries, or if you're in Canada, those levels are called becquerels, and that's 200 becquerels. Radon's not new. People say, oh, I've never heard of it. Well, it has been around and has been detected back into the 1800s. Madame Curie is one that sat on a panel that had discovered it in the United States. The presence of radon can be documented as far back as the 50s. In the 70s, the EPA started doing more research. There was a lot more lung cancers and health concerns, so they started to investigate it. And then it really intensified after 1984 with the nuclear power plant. And again, like I had said, 1987, the U.S. Environmental Protection Agency put into effect that an acceptable level in a living area was 4.0 picocuries or lower. I should say lower than 4.0 picocuries, or 2 working levels. Any type of system that has been installed is going to be classified as a radon mitigation system. Those will reduce the levels of radon. Again, when you go to the periodic table, you can actually see the components that make up radon gas. We have lead, we have bismuth, we have polonium, and then as you will see, radon itself, radium, has its own number. So what exactly is radon? Well, you as a home inspector have to explain to your client that there is a odorless, colorless, and tasteless gas that can give you cancer. It can do this. It has definitely been proven. It's the second leading cause of lung cancer, and it's the #1 leading cause of lung cancer in non-smokers. It's produced by the decay of uranium. It'll decay into radium-226 and then onward. It's natural occurring. It's everywhere. It comes out of rocks. Most soils contain it. When drilling's going on, especially like in Pennsylvania, New York, and some bits of Ohio, they're drilling and bringing up NORM, natural occurring radioactive materials, and those are actually being tested. It's a natural occurring gas, and as you see from this slide, it'll be in the ground as uranium, go into radium, radon gas, and it will emit. It'll go out into the air and dissipate naturally. This is a better option to explain how the decay process goes. As you see, it'll start out as uranium. It's measured in half-lives. As the uranium breaks down, it'll go into radium. It'll turn into a radon gas, which has a half-life of 3.8 days. And then what happens is the gas will then turn into a solid. And those are the polonium, bismuth, polonium, and lead. These are known as radon decay products. These are the alpha emitters that causes the cancers and lung cancers. As you see, the EPA has identified that about 21,000 to 25,000 deaths per year are related to radon. What will happen is a person will inhale the alpha particle, even though the alpha particle by itself, if it lands on your hand, you could brush it off, blow it away. But once it gets into the lungs, it sets in there and pulsates until it reaches a half-life, and then another half-life, and another half-life. So the higher the radon concentration, the more you're susceptible, or your clients are susceptible to getting lung cancer. There are many paths. As an inspector, you need to look at the basement or lowest lived-in areas and compare the cracks, open sump pits, well water. A lot of places still have limestone wells. Those are good indicators that there could be a presence of radon in water, and there is radon in water testing. And then the big scare that was released about 1.5 years ago was about granite countertops and granite floors and granite shower stalls and things like that. Can they be tested? Yes. But I will tell you, it would take a lot of granite to be installed into a home that is going to be classified as a major concern from the off-gassing of the radon that's in the granite. But as you see from this, it can be emanated through the cracks, sump holes, any type of drainage, any protrusions that come into a basement or lowest lived-in area. Radon levels will fluctuate with the weather, so while you're doing testing, this is why you need to take good training, approved training by the national providers. It will explain that whether as the barometric pressures start to build up, it will not allow radon gas to escape. Levels will spike. So if you're already even thinking about or have seen radon tests where in a continuous radon monitor, you have seen that there are a number of changes in the levels, it is actually due to the atmospheric pressures. The best way and the most accurate way to go is to do long-term testing. I know we don't want to hear that because as a home inspector, these properties need to be turned over quickly. We can do it with a continuous radon monitor and give a reading within 48 hours on site. But if you're in Canada, they will only allow long-term testing, and the definition of long-term testing is greater than 90 days. If you have a level that is below 4 picocuries, that means 3.9 and lower, that is an acceptable radon level, not 4.0. 4.0 and greater requires actions. So everything below 3.9 would be fine. In Canada, as you see below, it would be 5.4 picocuries, or an equivalent of the 200 becquerels per meter cubed. As you see, approximately 7% of all homes have an unsafe radon level. When you start looking into becoming an inspector in your area, you can go to the EPA's website and look at independent states and counties to see what range you are. They go in a red, yellow, and different colors that will tell you, hey, you have a problem in this county. When you get into actual counties, they'll do a red, yellow, and green. Biggest misconcept, being a radon professional for the amount of years that I have, is, well, my neighbor's house didn't test out, so that means I don't have it. It is not true. This is a true story. I did a test on a client's house and a neighbor's house. The neighbor's house tested out below 4 picocuries. His house, due to his construction method, tested at 427 picocuries. He actually caused his problem by building his house so tight he had no air exchanges, and when the wind would blow across the roof and across the ridge vent, it would actually depressurize the basement, and he had a floating slab. Lots of open areas where it could draw in the gas. Once we sealed those up, we actually did not have to install a system once we got some proper ventilation. So there's many ways that the levels can vary. Could be a source, could be the soil. I have seen already where a basement has tested out fine. They did an addition onto a home. They brought in fill from another area, and that room itself tested high due to what they have brought in. As you can see, just because you will hear other people say, well, because we have a basement, we'll have radon, and if we don't have a basement and we have a slab, we're good. We won't have radon at all. It's not true. It just depends on the amount of openings in the crack, the source, how permeable the soil is, and the easeability of movement from the radon and construction technique. The EPA has an actual indoor and outdoor level. The indoor levels, on an average, if you wanted to base this in your marketing tactic, an average level is 1.3 picocuries. An outdoor level is 0.4. That's how much it will dissipate once it gets outside. EPA has many different types of maps. You can go to your individual state, type in your location, and go by counties. I've used this in marketing tactics to help our members go out and get work. They'll say, well, we're not really in a radon area. A good example is in Florida. People say, well, there's a lot of houses that are just built on slabs. Radon's not a big concern. My answer to that is, if it was not a concern in Florida, Florida would not have radon laws, their own specific test, and a person that does radon calibration of equipment would not use the sand off the beach to calibrate his equipment because the beach sand tests out at 7 picocuries. Here's the actual EPA radon map. As you can see, the zones, Florida doesn't have quite as high of a zone. Texas doesn't have quite as high as a zone, but zone 2s are very comparable of having a lot of radon. And of course, zone 1s is about 1 in 3 homes, 1 in 5 homes have a radon concentration above the 3.9 picocuries. You can see in California, there are certain areas there as well. This is a map just specifically of Pennsylvania. I picked out a county, Lycoming County. That's where our corporate office is. And as you can see, in our county, it goes by zip code, and it identifies a lot of the areas that have high radon concentrations. The area that you see basically middle top, it's kind of in red. Those are the areas when I did radon mitigation were my highest areas. I have been involved in radon mitigation and testing with the Department of Environmental Protection where the levels were over 1,200 to 1,500 picocuries, and we were successful in getting those levels down. So how are the measurements? How do we do these? You need to understand there's a couple different ways. There's a short term and there's long term. Short term is the most popular in real estate transactions. But a short-term definition is less than 90 days. But they have to set at a minimum of 2 days or 48 hours. So more than 2 days, but less than 90. A continuous radon monitor, if you get the electric CRMs like the 1027s, 1028, 1029, some nuclears, the femtotech, those will last up to 72 to 96 hours of a test. But that's as far as they'll go. That's as far as they'll record. A charcoals are very easy, very cost effective. You can get them pretty much anywhere. You can go to AccuStar Labs, RTCA. They have a lot of the charcoals, and on average, you'll let those set for 2 to 5 days. Some of the charcoals you can get that'll go up to 90 days. Electrets, the ePerm system, this is the most popular system compared to continuous radon because the electrets have the ability to be set for long-term, short-term, and they are the most accurate on the market. What about long-term? What do we have that we can use for long-term testing? Let's say somebody buys a house and they say, now I'd like to have an idea of what it would be for a whole year. Well, we're pretty well limited in what we can use. There's something called an alpha track, and there's something called the long-term electret, and till recently there's now a continuous radon monitor that's called a Scout, S-C-O-U-T, and it is made by Femtotech, and it can be set for just around 91, 92 days and give you readings. This is an example of some of the devices that are available. The short-term testing, If you're going to use canisters, those are charcoals. They're packaged with charcoal inside the can. There's also a charcoal bag. AirCheck makes a charcoal bag that you can hang for, up to the 5-day period, and it will sample for the radon, and those are sent back to the lab. The electrets, those are very good, very, very accurate. It's a very nice system. It's a little costly, but it is a very good system. Continuous radon monitor, there are a lot of those that are out there on the market. 1027, we have sun nuclears that are 1027, 1028. 1028 sun nuclears have the ability to be programmed to kick on and kick off. The 1029s have the ability to not only kick on and off, they take a lot more measurements per hour and also induces relative humidity and temperatures while testing is going on. Canisters run about, for charcoal, they run about $25 to $35 a piece and include your lab fees typically. The Electret system, the EPERM system, you're looking at a system that's going to cost around $2,600, but you're going to get 6 Electrets that will get 70 tests apiece. To replace the Electrets, you're looking at a cost of about $25 to replace them. Continuous radon monitors, they can average in price from right around $550 to $1,400, and the femtotechs can range between $2,000 to $3,500. In long-term testing, the alpha track detectors, those are about the best. Most people forget they even have them. A year later, you would have to go back and get these. The alpha tracks are about the same cost. They're about $35 to $40, and the long-term Electrets are the same price, about $25 a piece. The difference between the Electrets and the canisters you have to send to a lab to be analyzed. So if you set it for 48 hours, you have to collect it, send it to a lab. Lab will now analyze it in roughly a day or two to then get your results back. Continuous radon monitors are right on the spot. The Electrets are right on the spot as well because you are the lab. You actually have a device called a reader that you put the Electret on, read it, do a calculation, and give your client the result. The advantages of a continuous radon monitor are great. You can print a report on site. It'll show you hourly readings. The 1029s will show half-hour readings. It will show tampering. If somebody unplugged a continuous radon monitor, not only will the battery backup kick in for 96 hours, it'll come up P for power, and you can see whether or not the readings start to go down. If the readings go down, you know it's been tampered with. If somebody so much as even brushes by the device, it'll come up T for tamper, shows movement, and then you would look to see whether or not the readings go down. Some have third-party verification. The Femtotech, some other ones out there, you can take and plug into a phone line, and it will do a third-party verification to say, yes, the readings are all correct. It'll go back to a computer and bounce back your reading again, and you can use that as third-party verification. Again, we just talked about with charcoal, pretty much cost-effective, $25 to $45, including the lab fee. There is no conflicts of interest with the results because the lab is giving you the result. You're going to be able to give the client a lab report, and it's pretty easy to set. All you have to do is unwrap the charcoal or open the bag and go from there. EPERMs, It's the most accurate device that is out there. You can typically get 60 to 70 samples per device. To replace that device, it's about $25. You get an instant result, there's no lab fee, and you can print the report. Testing time frames for continuous radon monitors. The minimum amount of time that you can leave one set is 48 hours. Maximum amount of time is 96 hours. They will shut down. They will stop reading. An active charcoal, it's a minimum 48 hours again, and they're most of the charcoals have a maximum of 96 to 108 hours, and that's about it. Some charcoals can be used for long-term, which is the Alpha Trax. That is a charcoal base, but that goes under a different analytical. There are requirements. There are requirements for testing conditions. There must be closed house conditions prior to and during the test. It's 12 hours. That's why the 1028s, and 1029s, and the Femtotechs are nice if you're using a continuous radon monitor, because you can program those to start 12 hours after you get to a house. Most people do not realize they have to keep their house closed for 12 hours. And the reason for that closed house condition is it has to build up pressures of a normal living environment. We're trying to imitate what we have now, which is winter, when heat is being run or any other items are being run during wintertime months. The doors are closed, the windows are closed, and air is very limited in the circulation. The next part, and this does fall by state, it's called lowest livable area. Some states define the lowest livable area as an area that is finished. Some states say whichever the lowest area is that could be lived in. You must check with your Department of Environmental Protection to see what they say, or when you go through a professional course, you will understand, because it will be covered in that course. You're not allowed to test in a kitchen or bath where a lot of water is exposed, because if radon is present in the water, it can give you a false positive reading of what's in the air. No ceiling fans or any type of air circulation fans are able to be operated in the area you're setting your test in, because that can skew the radon gas and the particles that are floating around. And especially if you're using items such as charcoal, you can actually blow the particles away from the testing device. The HVAC can be operational. We can't shut that down. Normal entry and exits are fine. And if you're doing a post-mitigation test, radon mitigation, after a system's been installed, you must wait 24 hours after the system has been installed and running to do your test. And again, continuous radon monitors are a great item for that, because you can program them to start 24 hours later. If you don't have one that you can program, you leave it set for 72 hours and omit the first 24 hours, and you record that. After a mitigation system has been installed, it is also a requirement that a test be conducted before the end of 30 days after the system has been started. Again, for all short-term tests, the windows and external doors on all floors have to remain closed except for the normal entry and exit. Any test that's going to last less than 4 days must have that 12-hour prior to the test, must be closed up 12 hours prior. And again, it must start 12 hours before the test begins for those that have less than 4 days. In a non-real estate transaction, there are different requirements. The EPA has specific guides that you can actually go get, you can download and give to your client. You can reproduce these. You have a buyer's and seller's guide to Radon, and you have a citizen's guide to Radon. In professional courses, of which we have and we're going to talk about later, we do include a copy of those so you can see this. This is what you would give to your client depending on who you're going to do this for. If it's a non-real estate, it could be in a lowest lived in or unfinished basement or in a finished basement. It is up to the homeowner and how you, the professional, see that they use their home of where the test needs to be done. It could be 2 tests. There could be a slab added to the home. You would test the basement and the slab. In real estate transactions, the EPA will recommend the testing at the lowest level of a home that can be lived in. But again, please check the different states. For instance, Illinois has a requirement that if it is a commercial or an apartment, it's all areas where the soil comes in contact with that space. To be a certified radon measurement provider, we must meet the mandatory state and provincial certifications and licensure requirements. There are at this time 19 states that have some type of requirement. For instance, Pennsylvania, Ohio, California, Nebraska, Iowa, Kansas, New Jersey, Florida, Illinois, and now Kentucky. At the first of the year, Kentucky went under the program. Other ones, such as Delaware, recommend you take a professional course recognized by either NRPP, National Radon Proficiency Program, or the NRSB, the National Radon Safety Board. Please be advised, if you live in Ohio or Florida or West Virginia, you must take a live class. Cannot be done distance, cannot be done as an online. You must go through a 16-hour live class. Other states, you can take distance learnings. Just real quick to give you an idea of these sites, NRPP, National Radon Proficiency Program, had just changed beginning the end of last year. ARST had taken them over. You would have been able to, may remember they were NEHA, National Environmental Health Association. They've now done away with that, and ARST now is taking care of what they're doing. The NRSB site, you can go there, you can take their exams. Each one of these has an exam. NRSB, we just got reapproved with them. They changed some things, and now our courses are up to date on those. To obtain your certification in those states that require licensing, you must complete a 16-hour class and take an appropriate exam. We're able to administer some of the exams. Some of the states have their own licensing exam. Illinois and Florida have their own exams. You must develop a quality assurance and quality control plan. We give that to you. You must maintain 16 hours of CEUs every 2 years. And whatever device you're going to use, you must send it away, have it analyzed, sent back, and then you must do a device certification. What do you charge? Well, it ranges. Average charge is about $150 as a standalone test. If you're doing it, including it with a home inspection, you can get away with about $90. But most people get $125 to the $150. On a post-mitigation test, I can tell you a lot of them include it with a mitigation system, but states that have the conflict of interest laws and require a third party, you get between 90 and 125. Who's your clients? Of course, the biggest thing, I can tell you, realtors, they are the biggest client for the radon. Right now, January is recognized every year as, and by the EPA, as Radon Awareness Month. Usually people who are radon certified see a big spike in testing between now and the end of February. But realtors are your prime source. They're doing the houses. They're going to know whether the tests need to be done. It's listed in their disclosure statements. Other radon mitigation providers may use your service as third party. Contractors that are doing new build, you can actually test the ground with certain things. And when you go through a class, you can actually test the ground and give them an idea whether the radon is radon-containing soil before they build. Schools, daycares. Illinois is getting ready to pass a law right now that says that daycares are going to have to be tested. In Florida, if a school or commercial building is built, every 2 years for the 4-year period, the initial test, 2 years and 2 more years, testing has to be done on those commercial buildings and schools to validate that they will not have a radon problem. So now we cover radon inspection and testing. Now I need you to be made aware of radon mitigation and how easy it can actually be lowered. The removal of radon is greater than 4 and less than 10. If we have that a level is 5 or 6 picocuries, the EPA recommends another short-term or long-term test. Over 10 picocuries, they'll make a recommendation that another short-term be done or go directly to mitigation. I can tell you in the years I've been doing this, if you have a radon level that is 6 picocuries or greater, it's going to go more than likely right directly to radon mitigation, and especially if this is a realtor transaction. There are 2 types of systems. There's an active system and there's a passive system. An active system is a system that is plugged in and is powered, that has a radon fan, whereas a passive system might have been installed by a contractor as the building was being built, or there's a contractor's stub in there. Passive systems in the states, in all the states, you do not have to be licensed to install a passive system. If you make it active, though, you must have licensing in 19 states. This is just a small list, and as you see, it almost mirrors the inspection. If you're thinking about going right directly into radon mitigation and you're in a licensing state or a state that recognizes NRPP or NRSB certification, there is a prerequisite that you must take a 16-hour measurement training before you take the 24-hour approved radon mitigation course. So what is a radon mitigation system exactly? The most popular is what's called a subslab suction or depressurization. It's where a pipe is installed below a slab and it's vented to the exterior and either powered by a fan, making it an active, or it's run through the house through an interior wall system and uses stack effect, and that will reduce the radon levels. Other things that are involved with radon mitigation when it's close to 4 picocuries, you can help your clients. You can give them recommendations. Mr. or Mrs. Smith, please seal the cracks and gaps that are around the basement perimeter. Any of the open sump pits, close and seal them off. Put a cover over top of them. anything that you can make recommendations, any penetrations that are around, will help lower radon levels. The EPA does not recognize those as a standalone, but it does help and is classified as radon reduction. There's another system called house air pressurization. The house air pressurization is where a fan might be turned upside down and it pressurizes the slab, or there is a system where they use a ventilation from the exterior and it pumps fresh air into a basement or slab area and pressurizes the room. Then there's just plain ordinary ventilation, crawl spaces where you can install block vents and have crossed air going through. If you make recommendations for this, please be advised and be careful. There are pipes that are out there that could freeze in the northern climates. Radon mitigation with a subslab. There's a pipe that's run typically through the home, and it will vent the radon out the exhaust to the outside, usually above a roof line. It is never at ground level. The only places that a radon system can be discharged 3 feet above the ground, or the fan can actually be mounted indoors, is in Canada due to their cold air climates. This is some examples. This is what you're going to see in an attic area, the one off to the left. That is in an attic. The fan is vented, or the exhaust pipe is vented through the roof. The fan is installed into the attic. In another unfinished attic, you have one that comes up from a below area and from another room and then is vented out through the side. The one, the upper right corner, that's a fan mounted on the exterior called 501. And then a basement where there's a sump pit. They utilized the sump pit, put a cover over top of it, and installed a pipe to draw out of the sump, a pre-made hole for depressurization. This is where the radon fans can be located. This is in the United States. Fans can be located in non-livable attics. They can be located on the outside of the building. They can be even in an attached garage, as long as there is no living space above. They feel that a fan, if it was to crack or a seal was to break, the concentrations that would come out of radon gas would be devastating to a person. So they cannot be in a livable area. They cannot be inside in a basement. They can't be below grade, and they cannot be in any living area or below it. That is the rules by the states. The radon vent pipe has to discharge to the exterior. It should be above the roof eave. It's got to be 10 foot above the ground for the discharge. Has to be 10 foot away from any door or window, and if it cannot be 10 foot away from any door or window, it must discharge 2 foot above it. And where possible, 10 foot away from any adjacent building openings. We do not want to be pumping radon gas into the neighbor's house. Post-mitigation testing is required. This is where you come back in and do testing afterwards, 24 hours after the system's been running, but it has to be done 30 days within that 30-day period. The systems, when they are installed on the exterior of a home, after a home has been built, they do not look pretty. As a mitigator, we try to hide them as best as we can. The big popular thing right now is a lot of the mitigators have found that with the use of standard siding, if a house has been built with standard color, you can actually get spray paint, spray the pipe, and make it match the siding, as the one is that you see in the lower right. That is not white pipe, that's actually gray pipe. They painted it. We try to hide it around bushes, we try to hide it wherever we can, but as you see, the discharges go above the roof eaves or 10 foot above the ground. Room ventilation. If there's basement systems that are installed, a basement dewatering system, they can actually be used as a radon vent where a pipe can go into it. Typically, in a basement dewatering system, they will drill holes into the block. You can take and put your pipe into that system and draw air from the block where there could be lingering radon gas and expel it to the outside. Or typically, just leave the windows open. Not going to get many clients that want to do that, but crawl space is the idea. If you have a crawl space, you can put block vents in and take out the shutter so that they can't shut it. That way it's always being ventilated and the radon gas will not be as high. Radon mitigation, it can be very profitable, just like the radon testing. A pre-installed system, $300 to $500. That's without a fan. A regular system, that's with a fan and the type of the system, they can start out at $900 and go as high as $3,000, depending on what it is. Some commercial places, like the EPA buildings and DEP buildings, when you become certified, they will contact you to have radon mitigation systems put in their systems. I had a gentleman come in that was a member who needed help bidding one. He did a mitigation system, put 5 pipes in with 5 active fans, and he got $12,000. And that was a pre-install as the building was being built from the EPA. Your clients, realtors, again, the test shows that it fails. They want an answer. They want to know, how do we get this taken care of? What do we do? Contractors, as they're building homes, you might be able to pre-install systems. Then if it needs to be made active, you could refer it out. Other radon measurement providers, and then general public during the times like January and February when it's the action month. The whole thing to understand, every home has a level of radon. Every home disclosure has radon mentioned in it. Radon, mold, lead, asbestos. Radon testing is the #1 ancillary service offered by a home inspector. It is the #1 most requested environmental test with home inspections. Your target markets are very specific to go after. As you've seen prior, it's realtors, it's other mitigators, or a general public announcement. And it is a very easy, cost-effective add-on service. I give a little table here that shows if you're doing testing using only one device, and that one device is set 3 times a week at $125, in 52 weeks you could equal $19,500 onto your already existing business. If you're setting that device 3 times a week with your home inspection, you just added another $19,000 to your home inspection business. Be in certain areas. I have a friend who is in Pittsburgh. He has 24 CRMs, and those are out all the time. Mitigation systems, you have a hard cost, fans, pipe, time, labor, $400 to $500 in hard cost on a system that you can get $900 to $1,100 depending on the system and what state you're in. But it is a very profitable business to be in. It's very viable and easy to do.